3D Printing Today, show number 381. Shrinkage on the belt. New extruders we want to try. Zesty Nimble version 3.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, it doesn't matter. We cover it all. My name's Andy Cohen, and I'm here with Mr. Whitney Potter. Hey, Whitney.
Hi. How you doing, Andy?
I'm doing pretty good. So today's news story is not necessarily news per se. It's more of just a really cool, fun thing that we want to share with everyone. I first saw this. Somebody posted the YouTube vid on our Google group forum. Unfortunately, since there's no way for me to find it, there's like the title of the posts are not on the subject, so I couldn't find it. So I apologize for not giving that one poster credit for the post on the YouTube vid of this. But thank you anyway. The in 3D printing industry, the title of their article that describes this is "Scientists Convert Low-Cost FDM 3D Printer into All-in-One Production Line Called Funktgraph." Now, I think they spelled funkt wrong. I think they should have spelled it with a K-E-D at the end and not a C-T, because this thing is just so much fun. It is cool.
And with a PH instead of an F.
Yeah, that would have been even better. Yeah. So this comes out of a university out of Tokyo, where basically they came up with this idea to explore having the 3D printer print the components of a miniature production facility, and then with the printed components still in place, I assume there's some assembly required as well as component additions. They turn the Mendel-based 3D printer into a automated production facility for little things. It's just so cool.
So basically they've added a little attachment to the side of the print head that allows it to pick up tools and pick up tools that have been printed on that printer. And they can also drop the tools by pushing up against another 3D printed part. So there's basically two parts that you have to add to the printer, and then after that, it's just all a matter of how clever you are.
Yeah, I think it's a function of the factory design that they're modeling. What I think this is excellent for is to teach automated production. This is a great way to learn how to develop robotic automated production. I don't think you would ever actually use this for automated production, such as building bologna sandwiches or toy cars. Don't think it would actually work for that.
The bologna and cucumber on Wonder Bread with no crust sandwich.
Yeah, you have to take the crust off.
Maybe it's popular in Japan.
You got to take the crust off to get them nice and uniform in the holder. But that's a function of automated production facilities, which is what you would learn when you develop stuff like this. So I think it's not just really, really fun to look at. It also provides a really high value learning experience for anyone who's involved in it. So I think it's a great idea. Will they show their process for how they do the development of these systems? I imagine that's part of their university program that you'd have to probably take part in, but still pretty cool.
They've probably got a paper on it somewhere, or they will pretty soon.
Now the article in 3D printing industry, which we do have in our show notes, I looked for it and I could not find the link to the YouTube vid, so we included the YouTube vid link as well as the link to the article in 3D printing industry. In the meantime, Whitney, what do we have on our show this week?
Let's see. We start out discussing shrinkage on the belt.
And we're going to discuss the new extruders that we've been finding that we really want to try.
And then we have a look at the Zesty Nimble V3.
Sounds great. Let's do it. So I'm still kind of certifying the iFactory 1. Maybe certifying is too too diplomatic a term. I'm basically banging away on it and seeing how well it works. Overall, it works brilliantly. I've had problems which have been solved, but here's an interesting one for you. So we learned even before it shipped that the iFactory guys made a mistake based on their lack of knowledge about belt 3D printers. They built the bed that goes underneath the belt with the heater going the length of the belt surface at the top where it prints on, or where the thing, the object that you're printing, rides along. And that's a problem that was pointed out to the folks at iFactory by Mr. Bill Steele, who helped the Creality folks. So the Creality folks already knew about it. The iFactory guys didn't. That heater can't travel the length of the surface of the belt. It has to be only about halfway, because you really only need it for a certain amount of printing height. And then towards the end of its travels across the bed, you want it to cool down, because as it is released from the belt, as the belt rotates underneath the roller, if it's still hot and soft, it will bend the object and warp it downward. Not good. Not good. Now, in the process of playing with it and printing away, I've learned that you didn't really need to use the heater, because the belt has such a deep pattern in it and a texture that as the plastic is placed onto the belt, the plastic kind of seeps into these physical fissures, tiny fissures, and that's kind of where it gets its grip and stick from. Same as with the build tack and blue painter's tape. That's how they all work. It's a mechanical bond versus a chemical bond that we use with PEI and with Aquanet, liquid vinyl. So I left the heater off, and it was working okay until while printing with PETG. Now, by the way, if you recall, we had a thing of the week a little while ago, the Book Nook, the Nocturne Alley Book Nook. Now, I decided I was going to build that, and I was going to try to use the iFactory one for all the interior parts that are detailed. The back, I was just going to do on my Race 3D, because you really don't see any detail, and it wasn't that big of a deal, and I can print them at the same time. So I've been printing these parts, and I'm doing them in PETG, and I noticed one part came off the belt, and these are large, thin, flat pieces, and the top surface is very detailed, like brickwork and woodwork and tiling. And it comes out really, really nice with the 45-degree angle, because the details are at the edge of the toolpath, which is where a 3D printer's resolution really shines. We could really see each time the change of direction to get the detail. And the iFactory one is working brilliantly. I'm getting beautiful surface detail. But I noticed after a while, I'm getting shrinkage, traditional shrinkage, the kind of shrinkage we see on most 3D printers where you're not heat soaking the part. And the way that looks is usually on the corners of a rectilineal object, straight line. Those corners are thinner because it's come up a little bit. The corners have pulled up. And so as the extruder goes over that area repeatedly, it's kind of squishing the layer thinner and thinner and mushing it. And so the corners come up a bit. And I've been noticing that on some of these parts. So I turned the heater back on, and that's diminished quite a bit. But now I'm getting the bowed effect from the soft plastic. So what I did was I took a piece of vinyl that I had, an old bill plate from my Rep 2 from many years ago, and stuck it right on the surface of where the belt goes down and away and the parts come off. And it's just the right height so that the belt kind of goes away, and it's just a touch lower than the surface of the belt before it goes down, so that as the part comes off the belt, instead of being pulled down, its edge stops on the build plate and continues and cools down. And that's diminished the warp significantly. It's really taken it away a lot. However, it's still there slightly. And what I've had to do is take each of these parts and turn on my Race 3D and the bed and heat it up to about 100 C, put something heavy on the part, put the part down on the bed and let it sit for about 10 minutes and soften everything up, and then I let it cool down and now it's flat. I do that a lot with parts that may warp or may change shape. It's a problem I'm not sure how to solve yet. I'm told by the iFactory folks that they're going to be replacing all of the early delivery beds with the beds that are going to come in March. And in these beds, the heater elements are much shorter. So there's a cool down period. And hopefully that will fix this warp that we're seeing.
It's going to be a little bit trickier to design that because you're going to have the bed with the heater element recessed into it, right? Because the bed has to stay perfectly flat after the heater element.
Well, the heating element is underneath, and It's an aluminum plate.
Yeah.
So that's okay. The assumption, though, that even Creality has made is that there will not be as much inductive heat across the surface of this plate. And I think there still be. The question is will it be cool enough as it travels away from the heater, because it's going to continue conducting the heat into the plate across. We'll find out when we get it. It shouldn't be too hard to replace the plate. I just have to loosen up the belt and remove 4 screws to replace it.
You could have down belt cooling fans. It could become a thing.
Yeah, that's probably not a bad idea, actually.
Or underbelt cooling fans. Actually, you could have cooling fans that were cooling the belt from the underside as it passed off the heating element.
Or another possibility is make the bed itself shorter. Instead of having the bed go the length between the rollers, make the bed end halfway. And so the belt's over empty space before it goes past the roller, and have a fan underneath that belt cooling it down. It's a bit of a problem. But in the vids that we're seeing with the iFactory versus the CR30, the CR30 does not seem to suffer from this same issue. And remember, the CR30 has a different belt. So I don't know. We'll see. We'll see what happens. Well, I got to say, man, this year we are seeing the most new extruder hot ends I've ever seen in all the years that I've been involved in 3D printing. I've never seen this many all at once. At a time when a lot of our extruder designs out there are getting really long in the tooth and are basically obsolete, we're seeing this long list of new approaches, new designs. And I'm not talking about the Copperhead. The Copperhead's been out for a while now. There's a couple of them out there that have been out there for a while now. I'm talking about some newer than that, newer stuff. But I'm going to start with the oldest of this list, because this extruder's been out since after we got the tool changer, but they're hard to get because thanks to COVID-19. In fact, thanks to COVID-19, a lot of these might be hard to get for a little while. But so this extruder hasn't been out in the wild enough yet to really hear a lot more about it. And that's the E3D Hemera. We do have one. We have an E3D Hemera, and I have yet to install it on one of our machines. So we really can't talk yet about what we're seeing with it. But its potential is pretty high, because what this extruder does, and the next one on our list does, is it minimizes that distance between the drive gears and the heat break, the thermal tube, and that should enhance performance enormously. We should be able to get much more reliability and higher speeds with this design. the other high competitor that from what I see is just now available to purchase is the Bondtech LGX. Just like the Hemera, it combines the drive gears as dual gears, very powerful approach. That's the typical Bondtech approach. They combine it with the heat break and the thermal tube, and they provide the system where the hot block and the nozzle can be any of a bunch of different types. So it kind of decouples all those functionality, yet it brings them all into a very tight package. Looking forward to trying that one. Knowing the Bondtech, its casing is probably going to be SLS printed nylon, whereas the Hemera is all machined. Let's see. The next one on my list that I want to try, I can't wait to try, is the Micro Swiss. The actual name of this extruder system is the Micro Swiss Direct Drive Kit for Linear Rail and Exoslide Systems. It's not as advanced as the previous two. There is quite a bit of distance between the drive gears and the beginning of the heat break of the extruder. In fact, there's even a piece of Teflon tubing between them. It's so long. But it's designed really well for this industrial slider, the linear rail design. I really like that. I've been having trouble trying to figure out how to actually install the Hemera on a linear rail design. I'm having trouble with it where I can get that distance just where I want it, whereas this design actually gives that to me. With the disadvantage is now there's a distance between the drive gears and the opening of the thermal tube.
It's nice. It's all machined aluminum and everything, so you can actually, you can see what's going on there.
Right.
And if your filament, goes sideways, particularly if you're printing with flexibles and stuff, I found like something like a totally enclosed extruder, like we see with the Bondtech, it doesn't mess up very often, but when it does, it's kind of a black hole, and you're wondering what's going on in there, and you have to take it all apart to figure it out. Whereas the Micro Swiss, their direct drive extruder is very open, and you can very clearly see what's going on. So I do like that about it.
Yes.
Although, yeah, I'm not awfully fond of having the Teflon tube in there.
Yeah, I agree with you. Both the Hemera and the LGX have the disadvantage for maintainability. When things go south in one of my Bondtech, say on the Raise 3D, it takes time. You've got to go in there, you've got to take it apart, and that could be a problem. Whereas this design, which also uses a dual drive gear approach, where drive gears are driven on both sides versus a bearing against a hobbed gear or a drive gear, this design has that same approach, which I like. And like you said, everything's exposed. Although this particular design does not lend itself well to understanding where you're going to put your cooling fan. They don't say anything about that. I think they just assume you're going to figure it out. So don't know about that part. Okay, next one. Next one on our list is the new Zesty. Zesty has a new Nimble of version 3. I don't believe there's an image out there for it yet. The Zesty guys have been kind of out of touch since the pandemic hit the world, and they haven't really been out there and selling their products, so they kind of went back and kind of did a redesign of the Zesty Nimble. One of the weaknesses of the Nimble, because it uses this rotating Bowden drive, a kind of a wire that drives remotely, is that as your extruder moves around, that attachment can be stressed. So they've come up with a way of letting that attachment rotate to the optimal angle for your installation. And I assume it's not freely moving, because that would affect the drive gear. I assume that once you find your optimal angle, you then cinch it and it stays in place. We're waiting that. We're going to be beta testing that for the Zesty guys on the tool changer. And then the last extruder that's out there is from China. It's a clone, a copy of a couple of designs Of course, the Chinese have copied the Bondtech approach, and they've taken it a couple steps further. Rather than using SLS nylon, they've actually milled aluminum, so you can purchase a BMG that's all aluminum. I don't know what advantage that provides you. It's going to be a little heavier. It will pull heat away better. It will induct heat a little better than the nylon would, but I've never had that as a problem. However, of those designs, the one I would want to try is the one, there's one out there that uses, let's see if I could find it. I think I lost it because we have so many of them up there. This one's referred to as the mellow left. It's a left orientation. There could be left or right. BMG wind by metal, not all metal. And this particular one, they used the front casing. They've machined it in the same design as the E3D Hemera, as a heatsink, direct heatsink that flows off the sides. And the casing looks like an injected molded polymer of some kind, and it's clear. You can see through it. This looks really interesting, actually. The price's maximum is $62.68, so this is the least expensive of all of the new ones that are out there. This may have some potential, even though it's a clone. It's a clone of the Hemera's heatsink and of the Bondtech BMG, but it looks like they've done some rather serious engineering here. But of course, like just about everything you buy via AliExpress and Alibaba, the devil's in the details, and when you get hold of it, it may not be as great as it seems, but it may be worth checking out and trying. You never know. I've seen V6 clones that actually perform better than the E3D. I've seen Titan clones that perform better than the E3D. So it's worth trying, given how low cost it is. One thing's for sure, it's pretty exciting how many new hot ends are out there and extruder elements are out there. It's really cool.
You definitely got a lot of choices now that we didn't have when this all started, 6 years ago?
Yeah. So folks who've been listening to the show may recall that when we got the tool changer, we were not getting the results we wanted from the tool changer because of the fairly long Bowden tubes coming out of Titan, E3D Titan feeders, that they worked great if the object was larger. But when we printed like a standard sized benchy, one material worked great, did brilliantly. But the moment I started splitting it up into multiple pieces to print it in multicolors, I found that for some parts, there wasn't enough, there's a word for it, command authority on the flow of the filament. It required a lot more control. And when you have a really long Bowden, you get this compression and stretching of the filament as it's getting shoved in and out of the hot end. And that little bit of compression, that little bit of stretch and compression, you can do things in your slicer to minimize that with one color, with one material. And you can do it with multiple materials so long as you have a length of run to offset it. But if the tool path is really tiny, a really small tool path, there's not enough time in the tool path for that to even out. And so what we were finding is for things like, say, the little tiny buttons on a little object, like a teddy bear or a piggy bank with buttons on the chest, the surface quality where the button color ended and the jacket color started wasn't as good as it should be. Didn't get as good an effect as we did with the palette from Mosaic. And so that wasn't working for us. We had to find a new solution. You were given a Zesty Nimble version 1.5 as a review, which we never found a printer to put it on. You sent it to me. I bought a longer rotating cable, and I put that on the tool changer with really good results with two colors. I then went back and ordered 3 more Nimbles from the Zesty guys out in Australia. It turned out we got version 2 of these Nimbles, and we had to wait quite a few months to get them. And end result was we got the results we were looking for. We ended up getting the quality on the tiny tool paths that we were looking for. Okay, so we're fans of the Zesty Nimble for the tool changer. The Zesty Nimble will probably work really well also for the iFactory 1 and the CR30s, which are both Bowdens. So if you're ever in a situation where you need to change filaments, say with the 3D Chameleon or a tool changer, and you need a direct drive, the command authority on the filament, the Zesty Nimble is a great solution. It works. Now, pandemic hits, and I'm trying to find out from them, if there's, if I can promote their product, and it turns out I get this message on their webpage that says because of the pandemic, they had issues with their suppliers. They had to cease operations, which was very sad.
That's too bad.
Yeah, it was really sad. And about 6 or 7 months went by, and I kept trying to contact these guys, and I actually got an email back from one of the folks there, Brian, who said that they are trying to reboot the company, get going again, and in the process, they were looking to redesign for a third time. So now they're coming out with version 3 of the Zesty Nimble, and their motivation for doing that wasn't necessarily quality of print. It was so that they didn't have to have multiple products, because they did have a secondary product called the Sidewinder, and the Sidewinder brings the rotating cable in at a different angle. So they came up with a design that lets the end user of this device to position the angle at which the rotating cable enters the body of the Zesty Nimble and transfers the energy to a gear, which then goes against a worm gear. So you can, in version 3, you can basically rotate that position and change it. Not in real time, of course, because of course that would change the rotation of the cable. So it's kind of a fixed location. You find your optimal angle and then you bolt it all together. Well, they sent us a beta unit, and I got to say the quality of the print that I got was excellent. And the quality of the print that I got in version 2 was excellent. And the quality of the print that I got in version 1 was excellent. And they're the same. I get the same quality across the 3. I get no obvious impact to the use of the rotating cable at all. I don't get any slop at all. I get complete command authority to the same extent that I do with a dual hobbed gear Bondtech. So there are people out there that argue against using this kind of a system. I say to them, well, my first-hand results with all 3 versions say it works great. That rotating metal cable works fine. It's not a compromise at all. And it provides you with an ability to solve a problem that you couldn't with a Bowden or a direct drive. So with a tool changer, a direct drive is problematic because it puts a ton more mass onto your tool, and the tool has added mass to begin with because of the mass of the tool holder on the carriage on the gantry. So now you're doubling the mass and the weight. You don't want that. The Zesty Nimble is the perfect solution for this. So the version 3 has one advantage specifically for the tool changer that the previous versions didn't have, that I got to say, I'm thinking maybe I should just turn them all into version 3s, and that's they've optimized the mount. So now you can put the mount for the Nimble on the OEM tool changer part. See, the parking part on the tool changer for the tool is a metal part with tight tolerances that go into these 2 pins and rare earth magnets that hold them in place. Well, the previous 2 versions, you had to 3D print that part. With version 3, you can bolt a secondary mount onto the OEM metal mount, and now you get an optimal parking capability for the tool changer. So version 3 is a big upgrade for tool changer users. I would recommend it. It's a thumbs up for me. It's worth the wait. I would contact the Zesty guys directly and get on their waiting list for it, because I can tell you right now it's likely to sell out. They only make a specific amount because they're not a large concern. I have heard they have some V2s still in stock, and the V2 worked perfectly. If you're interested in getting a Zesty Nimble, and now's a good time to jump in there. Oh boy, Whitney, another show written to our hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, thank you all for your support on patreon.com. Thank you for your positive reviews wherever reviews can be made. And thanks for listening. We do it for you. We do it for fun. No advertising. We're not doing this for any income. We just enjoy doing it. I got a thing of the week this week.
Uh-huh.
Was walking around the hardware store. So I remember when I first bought my 3D printer, I walked through the local hardware store looking for things I could print myself that were on the walls. And I found dozens of things. I would take a picture of it with my phone, and I would go home and I would think about how I can print that. Well, here's one of those that I didn't design, didn't come up with, that is really, really cool. And it's also a really good example for something that you want to make with a bit more durable material. It's called the latching broom holder. The original came out quite a ways ago, back in January of 2017. And that is thing number 2029895 that comes to us from a Thingiverse user called Greg Frost is his handle.
Now, Greg Frost actually is sort of part of the roots of the 3D printers we're using now, because you remember the Wade's extruder?
Yep.
You remember Greg's Wade's extruder?
I sure do.
That's Greg Frost of Adelaide, Australia.
Yeah, some great stuff has come from Greg. We appreciate what he's done for the community. This original thing is a customizable version where you can change its size and certain aspects of it. But we also want to give a mention to a remix of this, which has come out fairly recently, last March, called the Broom Holder SolidWorks, which is thing number 4780890 from a Thingiverse user whose handle I can't pronounce because it's
I can't pronounce his handle either, but his actual name is Philip Weber.
Yeah. And Philip took the original design from back in 2017 from Greg, and it's not customizable, but what I like about what Philip did was he made it so that you could bolt. There's like tabs on the sides that make it easier to bolt to the wall. And he also designed it so that it's print in place and so that you could then enter a 3mm bolt into the 3 holes. So all you got to do is print it with a good material and then just simply insert the 3 bolts into the 3 holes. Now there is yet another remix, but we're not going to mention it here because in this remix it's print in place with the pins that actually hold it all together. In my opinion, that will not work because of the material just won't be able to handle the weight of the broom and the way you're going to be using this. Now I tried printing this in PETG and PETG failed. PETG could not do it because in that tight curves, and those tight curves in the back of the hinged part, the PETG splits. It splits from the shells to the tops, bottoms, and infill because that's where all the tension is for the spring effect that it gives. Now, the broom holder, obviously, you take your broom and you pop it in here and the jaws clamp shut on the broom, and you grab the broom, you pull it out, and the jaws pop open, and there's a spring action that keeps these parts in place. What worked really, really well for this part, and we're going to talk about this material in much more detail in a later segment, is the nylon plus infused carbon fiber worked brilliantly for this part. And I would think any kind of nylon with a fiber like a glass fiber would work really well because you need the durability and you will need the tight tolerances for the hinges for it all to work correctly. But this thing worked great. I printed like a bunch of them and using them in my shed and in my garage. And if I was to buy this at the hardware store, for the cost of the materials and my time, it would actually have cost more from the hardware store. So here's one example of where it made sense, money-wise, for me to just print my own rather than buy them from the hardware store. I did see them at Friedman's last week, by the way. They were not cheap. They were not cheap, and they didn't look even close to as durable as these guys printed in nylon. If you've got a tip, a question, or a candidate thing of the week, don't hold back. Send us an email. Send it to
info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
We also invite you to our Google group forum. Go to Google, search 3D printing tips and tricks. And when you get in there, if you want to post, you have to hit that join button. And we still have our Facebook group. If you go onto Facebook and search 3D Printing Today, number 3 and 3D in 3 separate words, it's an open group. You're welcome to join there as well. Let's see. We have a show next week, Whitney.
We do. Show number 382. We start out talking about the last 18 months.
Yeah, a lot of things have happened in the last 18 months in 3D printing, besides the pandemic. We're going to look at purge, prime, and wipe for multi-materials.
And then I scan the van.
I guess that's it.
Great. Thanks for listening.